Welcome back. Today we're going to be talking about rational number operations, day number 4. Obviously, this is a very important thing to know for 7th grade, so it's important that we feel comfortable before moving on. Our content objective is students will be able to find the product and quotient of rational numbers. Language objective is students will be able to reason verbally how quotients change based on a dividend or divisor. Why am I learning this? Well, it's important for many real-life problems like calculating how many calories are in part of a serving of food. So background knowledge, we've multiplied positive and negatives before. We've learned to turn them into improper fractions, check to see if we can cross-reduce, and then simply multiply across to get an answer. If we have an improper fraction as such, we would go ahead and turn it into a mixed number, and that would be our product. Now with division, we did the same idea. We've turned all our mixed numbers into improper fractions, and then we would multiply by the reciprocal. So the first fraction doesn't change at all, but the second fraction, we would take the reciprocal of it. We would check if we can cross cancel. And once we've done that, we'd multiply straight across, and that would be our quotient. We even practiced it with decimals as well. So here are some examples we've done in the past. Now, we've also talked about what the different parts of a division problem and the parts of a multiplication problem is. Here, this number, the very first number, is called your dividend. The one that you are using to actually divide is called your divisor, and the end result is called your quotient. Now, when we're talking about multiplication, the two numbers are called factors, and the end result of a multiplication problem is called your product. So now looking at number 1, it says, will the product of 3/4 and 1/4 be bigger or smaller than each of the factors? Answer without actually finding the product. Explain. Well, it means that we have 3/4, and of the 3/4, we're taking 1/4 of it. Well, first of all, we're starting with a small number, it's not even a whole number, and we're taking 1/4 of a small number. I expect it to be smaller, okay, because I am taking 1/4 of 3/4. So now let me actually show you how to find the product. I would simply multiply straight across. First, I need to check if I can cross cancel. 3 and 4 have no factors in common. 1 and 4 don't have any other factors in common other than 1. So if you multiply straight across, you would get 3/16. Number 2, explain the value of the product 3/4 times 2. Will it be bigger or smaller than each of the factors? Answer without actually finding the product. Well, I take this as 3/4 times 2, as I'm going to repeat 3/4 2 times. Now, if I take 3/4 and I repeat it 2 times, of course, I would expect the answer to be bigger, okay, because I'm taking 3/4 and I'm repeating it twice. So that is definitely going to give me more than 3/4. However, if I double 3/4, that would give me something less than 2. So let me go ahead and prove it to you by simply multiplying 3/4 times 2, kind of imagine it being over 1, and you'd get 1 1/2. Number 3, explain the value of the product 3/4 times 5/10, aka a half. Will it be bigger or smaller than each of the factors? Answer without actually finding the product. Well, if I take 3/4 and I take half of it, of course, it's going to be smaller than 3/4. Now, would it be smaller than a half, though? If you take 3/4 and take half of it, it will definitely still be smaller than a half. So my answer is it's going to be smaller. Now, let me go ahead and prove it to you by multiplying 3/4 times 1/2. Notice it would be nice if you turned the half into a fraction. So that would give me 3/8. So here, let me just prove it to you real quick. I could have done 3/4 times 1/2. Saw that I couldn't cross cancel, multiply straight across, and get 3/8. Now, could you have possibly turned 3/4 into a decimal as well? Absolutely. But my personal preference, especially for 8th grade material later in the future, is it would be best if you kept things as fractions. Now, will there be times where decimals is probably a better choice for you? Absolutely. But when can go either way, I definitely suggest you practice converting numbers into fractions. Okay, now let's take a look at some division problems. For number 4, it says, will the quotient of 3/4 divided by 1/4 be bigger or smaller than each of the terms? Answer without actually finding the quotient. Well, if I take 3/4 and I want to see, because division is, you're basically checking how many of the divisors could fit into your dividend, how many 1/4 will fit into 3/4. Of course, I expect it to be larger, because for example, I would expect there to be 3 1/4 to fit into 3/4. So I'm definitely know that this is going to be greater than both of them. Okay, so let me go ahead and divide and show you. I'm going to keep 3/4 the same, but multiply by the reciprocal, and that would leave me with 3. And of course, 3 is bigger than 3/4 and 1/4, so there you go. What about number 5? Will the quotient of 3/4 divided by 2 be bigger or smaller than each of the items? Sorry, than each of the terms. Explain without actually finding the quotient. So here, again, you're trying to figure out how many 2's will fit into 3/4. Well, first of all, a whole 2 is not going to fit into 3/4, so we already know it's going to be a fraction. And since it takes at least 3 of these to make a 2, I would go ahead and say that it's going to be smaller than both 3/4 and 2. Okay, so basically, if I show you the division, I take 3/4 divided by 2, which is the same as 3/4 times 1/2. I would get 3/8, which further proves that it is smaller than both 3/4 as well as 2. Last but not least, will the quotient of 3/4 divided by 1/2 be bigger or smaller than each term? Answer without actually finding the quotient to explain. So if you take 3/4 and you check to see how many halves will fit into 3/4, well, I would assume at least 1 would fit into it, half of it. So I'm going to expect the answer to be more. Okay, it is going to be greater. And again, let me go ahead and prove it to you. Take 3/4 divided by 1/2. Multiply then by the reciprocal, so you have 3/4 times 2, which ends up being 1.5. Now, let's go ahead and practice estimating before we actually start calculating. So here, what is -9 times -8 and 1/4? Well, I imagine -9 is -9, and -8 and 1/4 is about -8. So I'm going to expect my answer to be around 72 approximately. So now actually doing the math, by the way, this symbol here looks like some waves in the ocean, is the approximation symbol. So now that we have an approximation, we know where our answer should be around. Now, for example, if I got 17, now that would obviously be off. So kind of use these estimations to remind yourself my answer should be around this number. So to actually do the calculations, I'm going to go ahead and turn -8 and 1/4 into a improper fraction, sorry. So it's a -9 times -33/4. Notice I went ahead and put a 1 underneath the -9. That way I can see them as a fraction. So this way I can easily check to see if I can cross cancel. Unfortunately, I can't. So I'm going to multiply straight across, leaving me with 297 divided by 4. Now that this is improper, I need to turn it into a mixed number simply by dividing. So 297 divided by 4. 4 cannot go into 2. It can go into 29 7 times. With the remainder of 1, bring down that 7. This goes in about 4 times with the remainder of 1. So my answer is 74 and 1/4. Now, is that pretty close to 72? Yes, so my answer is definitely reasonable. So for number 7, again, you want to estimate. -3 1/3, it's about -3. 7/9 is about to me, it's pretty close to 1. So -3 times 1 is approximately -3. So actually doing the math, I'm going to go ahead and turn this first mixed number into an improper fraction, which is -10/3 times 7/9. I'm going to check if I can cross cancel. Unfortunately, I can't, so I'm going to multiply straight across, leaving me with -70/27. I know right away my answer is going to be a negative, so I would want to do that first before I go and do some side work as I turn this into a mixed number. 27 can't go into 7, but it can go into 70 about 2 times, which is going to leave me with, let's see, 54. That's going to leave me with a remainder of 16. So I'm left with 2 and 16/27. And again, since I already left that negative there, there's no way for me to accidentally leave it off. So it's a very good tip for you to decide the sign before you actually go and do some side work. Now looking at number 8. Again, very first thing we want to do is get an estimate. What should our answer be around approximately? 5 1/4 is about 5, and 3/4 is about 1, and it is negative, so I went ahead and put -1. Now 5 divided by -1 is going to be approximately around -5. So let's go ahead and actually do the work. We're going to turn 5 1/4 into a improper fraction, which is 21/4 divided by your -3/4. Now, something that I really want you to be very careful about is this. Sometimes students try to do too many steps at one time. What am I referring to? Some students try to turn the mixed number into improper fractions and at the same time multiply by the reciprocal. Be very careful. A lot of students try to do both of it at the same time and they end up not doing enough. Some students forget to multiply by the reciprocal. So please take it as one step. I'm going to turn everything into improper fractions and then take the very next step to go ahead and multiply by the reciprocal. So notice here, I just turned it into an improper fraction. I didn't try to do more than that. I do understand that dividing by -3/4 is equivalent to multiplying by the reciprocal of it. So by taking the reciprocal of this, it's the same as multiplying 21/4 by a -4/3. Real quick, let me just say right now, a positive divided by negative is a negative, so I'm not going to lose sight of that. In fact, that should have been one of the very first things that I've done so that I don't get the answer wrong for getting a negative. You're going to first check if you can cross cancel. 4 and 4 have a 4 in common, so we're going to go ahead and say 4 divided by 4 is 1. 4 divided by 4 is 1. 21 and 3 have a factor of 3 in common, so 21 divided by 3 is 7, and 3 divided by 3 is 1. Now at this point, we're just going to multiply straight across. 7 times 1 is 7, 1 times 1 is 1. My answer is 7, but wait, notice right here, I already put that the answer is going to be negative, so I'm just going to have to tack on that it's going to be a -7. Now for number 9, we're going to go ahead and do some division and see if we can notice a pattern. For example, 12 divided by 12 is 1. 12 divided by 6 is 2. 12 divided by 4 is 3. 12 divided by 3 is 4. 12 divided by 2 is 6. And 12 divided by 1 is 12. Now, 12 divided by a half is actually 24. 12 divided by 1/3 is 36. 12 divided by 1/4 is 48. 12 divided by 1/6 is 72. And 12 divided by 1/12 is 144. What did you notice? Hopefully you noticed that when you're given a dividend, the smaller the divisor, the larger the quotient. And the larger the divisor, the smaller the quotient, which makes sense. If you take a number and you're dividing it by a number that's really small, you're going to have a lot. But if you take a same number and you divide it by a large number, you would get less. Kind of think of it as I have pizza. The less people I have to divide it with, the bigger the piece I get. The more people I have to divide it with, the smaller the piece I get. Okay, so now let's take a look at number 10 and continue on. If I take 1/2 divided by 12, that's 1/24. If I take 1/2 divided by 6, that's 1/12. If I take 1/2 divided by 1/4, that's 1/8. If I take 1/2 divided by 2, that's 1/4. If I take a half divided by half, half divided by 1, it's a half. Now, 1/2 divided by 1/2 is 1. 1/2 divided by 1/3 is 1 1/2. 1/2 divided by 1/4 is 2. 1/2 divided by 1/6 is 3. 1/2 divided by 1/12 is 6. Again, what did you notice? Again, you should have noticed that for any given dividend, the smaller the divisor, the larger the quotient. And the larger the divisor, the smaller the quotient. So again, think of it as a pizza. The more people you have to share it with, aka the bigger the divisor, the smaller the piece you get. Or reverse, the less amount of people you have to share your pizza with, the bigger the slice you would have. So real quick, a rational number is basically any number that can be written as a fraction. Okay, so all of these are rational numbers because I can express it as a fraction. But the official definition is it's basically any number that can be written in the form of a over b with the fact that b cannot be 0. So, what might you conjecture about 12 divided by 0, and what might you conjecture about 1/2 divided by 0? These are referred to as undefined quotients. If 12 divided by 0 is 0, you would expect, if I worked my way backwards, that 0 times 0 is 12. Unfortunately, that's not true. And why am I using that? It's kind of in the sense, it's the same as saying, hey, 12 divided by 2 is 6. And I know this to be true because 6 times 2 equals 12. So notice here, this doesn't work the other way around. If you claim it's 0, I should be able to work backwards and say 0 times 0 is 12. But that's not true. Why? Because 0 times 0 is not 12. So we are referring to this as an undefined quotient. Any non-zero number divided by 0 is undefined. If you think about it, you can't take a number and divide it into no pieces at all. Okay? So 0 divided by 12. Now, is this okay? The answer is yes. It's possible to have nothing and divide it with 12 people, for example. It just means each person is going to get nothing. So, and I can prove it. I can say, hey, 0 times 12 actually gives me 0. And 8 divided by 2 is, well, I know it's 4, and I can prove it. I can say 4 times 2 gives me 8. But again, if I have 12 divided by 0, you think it's 0. But does 0 times 0 really equal 12? The answer is no. So that is undefined, which is why you can't divide by 0. So it is called undefined. So 21 over 0 is undefined because, again, you can't divide by 0 because anything times 0 is 0. It's not going to give you your 21 or your 12 that you would want from the other example. Negative 17.2 divided by 0 is undefined because if you think of it as this, it's the same idea, 17.2 divided by 0. It looks the same. So notice it could be expressed in two different ways. It could be expressed as a denominator, or it could be expressed as your divisor. Now, 0 divided by 15 is not undefined. This is just 0. And I could prove it because I could say 0 times 15 really equals 0. Now, 0 divided by 3.3 is, again, 0. Because, again, I can prove it. I could say 0 times 3.3 does actually equal 0. Now, 0 divided by 0 or 0 over 0, what is that? We will discuss this next year, so don't worry about it now. Well, guess what? That concludes our lesson for today. Thank you so much for tuning in. And as always, until next time, bye.